Good morning, besties. It is Miss Heard. This is now my 5th attempt at recording this video, and honestly, at this point, it is now 1:24, and I'm trying to go to bed. Like, this is too much for me, but I love you guys so much, so I'm just gonna keep going, and hopefully, I'm able to record this and post it. And yeah, so let's just go ahead and get started. Let's make sure that we're paying attention. We're not on our phones. We're not distracted. Give yourself the time to study a little bit for your Regents exam that's coming up on the 20th. We're going to kill it. And the way that we're going to kill it is to prepare ourselves. And what we're doing today is trigonometry practice. There's about, I think 10 or 11 questions on this worksheet. I posted it yesterday, so it's on the stream. It's under trigonometry. I will post the solutions soon. I keep saying that and I'm just not posting the solutions, but I'm going to post the solutions soon. So let's make sure that we're paying attention and pay attention to my instructions, because throughout this video, I'm going to ask you to do a few things. And if you do it, then you will be rewarded. And if you don't, then you won't be rewarded, but you won't be penalized. So if you're paying attention, stay tuned. So we have number 1, it says that we have this diagram that shows a ramp that's 30 feet long leaning against a wall at a construction site. So they were nice enough to give us a diagram. We know that if we are doing trigonometry or any kind of word problem, if there is no diagram there, we give ourselves a diagram. But they were nice enough to give us a diagram for this example. So it says if the ramp forms an angle of 32 degrees with the ground, how high above the ground to the nearest tenth is the top of the ramp? So from the ground to the top of the ramp. So I need to start at the ground and go to the top of the ramp. So I think that I'm talking about this segment right here. And what they're asking me is how high above the ground that is. So what is the length of that segment? So let's call that X. Now, this is multiple choice. So you know that I am going to first start by figuring out what can I eliminate based on the markings. I see that I have a right triangle. I see that my hypotenuse is 30 feet because it's opposite my right angle. So I know that that has to be my longest side. So if I'm being strategic, I know immediately I'm getting rid of number 4. Number 4 is honestly a ridiculous answer, because if my ramp is my hypotenuse, that's the longest length that I have. And honestly, I think that even 3 is ridiculous because it doesn't look like it is 5 feet less just by looking at it. Now, I mean, that you have to be comfortable with making those assumptions. So if you're not comfortable, just get rid of the one ridiculous answer that you see. But for me, I'm looking at this diagram, and yes, these diagrams are not drawn to scale usually, but I don't think it's going to be 3 or 4. But let's try to figure out what it is. So I'm looking for a side, and I'm given one side and an angle. Now, if I was given 2 sides, I'm going to use my good old faithful, which is Pythagorean theorem, which says a squared plus b squared is equal to c squared, where my c is my hypotenuse. However, I'm not given that second side, so I really can't use that. So I got to use trig. And to use trig, the first thing I do is label my diagram. So where am I standing? I'm standing here at 32 degrees. So if I'm standing at 32 degrees, I'm going to draw my arrow, and what's directly across from that is going to be opposite. I know my hypotenuse is across from my right angle, and at this point, I don't know anything about adjacent. There's nothing there, so I'm not even going to label it, because why? There's nothing there. It doesn't help me. So then I'm going to write SOHCAHTOA, and I need to know how to spell it. SOHCAHTOA. And what I'm going to do is I'm going to look for which function uses opposite and hypotenuse. And I'm going to notice that's going to be sine. So sine of what? Sine of 32 is equal to opposite, which I've labeled x, over hypotenuse, which is 30. And ultimately, I'm looking for x, so I can cross multiply. And x is equal to 30 sine of 32. And at this point, I don't know what this is, and I can't do this in my head. So I'm going to go over to my calculator. And whoops. I'm going to go over to my calculator, and I'm going to first check to see that I'm in degree mode, and I am. Thank you. And I'm going to put in 30 sine of 32. And then press enter, and I should get 15.8975, blah, blah, blah. It doesn't matter because they said round to the nearest tenth. So that's going to be option number 1. Number 2, we have this diagram of right triangle ABC. BC is 12. They've labeled that for us. Measure of angle C is 40. And what's asking us is which single function could be used to find AB. So AB is the side length. Again, I'm using trigonometry because I don't know all of my side lengths, or at least 2. I don't know 2 of them, so I can't use Pythagorean theorem. And it's asking us which single function could be used. Well, I know if I know that angle C is 40, then I can go ahead and label my diagram. This would be opposite. This would be adjacent. I know nothing about my hypotenuse. So if I write SOHCAHTOA, the function that uses opposite and adjacent is going to be tangent. So I know if using this diagram alone, I can use tangent of 40 is equal to x over 12. Now, if I go down, I don't see tangent of 40, but I know that if I'm using 40 degrees, I have to use tangent. So I'm going to go ahead and eliminate 3 and 4 because I can't use cosine for 40 because cosine needs hypotenuse and so does sine, and I don't have a hypotenuse. Now, 50, I'm wondering, where's 50 coming from? Well, 50 is going to be that complementary angle because this is a right triangle. So if I'm standing here, I have, again, opposite and adjacent. Now, I'm still using tangent. I'm not using sine, so my option is number 1. Now, I could have gotten rid of sine already because I already know that I can't use sine because I don't know my hypotenuse. The only option that makes sense here would be tangent of 50, and I'm just using the angle that's complementary to angle C. Complementary means sum up to 90. Equal 90 degrees. Capiche? All right, let's move on. Okay, so the angle of elevation from a point 25 feet from the base of a tree. Well, I don't have a picture, so before I even get started, I'm going to draw myself a tree. And we have the angle of elevation from a point 25 feet from the base of a tree. So this is my tree. This is 25 feet away. And we're talking about the angle of elevation. So I'm looking up. And where am I looking up? To the top of the tree. So maybe here. So that angle of elevation is 30 degrees. And it's asking us which equation can be used to find the height of the tree. Well, the height of the tree would be x. Well, if I'm taking a look at the diagram that I drew, I'm going to figure out where I'm standing. And I'm going to label. So this is opposite. And this is adjacent. I know nothing about my hypotenuse. So if I'm using SOHCAHTOA, I want to figure out which function used opposite and adjacent. That's going to be my tangent. So tangent of what? Tangent of my angle, which is 30, is equal to opposite, which is x, over adjacent, which is 25. So that's option number 1. Oh my God. I can immediately get rid of number 4 though, because this is Pythagorean theorem. And while Pythagorean theorem is used to find a side, I know that 30 degrees wasn't a side measurement. 30 degrees was not a side measurement. 30 degrees was an angle. So I can't say angle squared plus side squared is equal to. That just doesn't make any sense. So maybe I didn't know if it's 1, 2, or 3, but I'm definitely not choosing 4. 4 is my ridiculous answer. Number 4, for the acute angles in right triangle, sine of 4x is equal to cosine of 3x plus 13. What is the number of degrees in measurement? Number of degrees in the measure of the smaller angle. I'm sorry, y'all. It's 130. I don't even know how to read at this point. But we're looking for the smaller angle. So we know that we have acute angles in a right triangle. So acute angles in a right triangle are complementary. That means that those two angles add up to be 90 degrees. So let's take a look at the options before we do any math. Let's take a look at the options. So if my smallest angle was 11, that means that my bigger angle has to be 79. If my smallest angle is 13, that means that my biggest angle has to be 77. That's its complement. If my smallest angle is 44, my bigger angle has to be 46. And if my smallest angle is 52, its complement is 38. And that wouldn't make any sense because if 52 is my smallest angle, then its complement has to be bigger than that. And 38 is not bigger than 52. So we can immediately get rid of option 4. Now, I'm looking at 4x and I'm looking at 3x plus 13. And I notice that we're multiplying x by 4 and then x by 3 and then adding 13. So in my head, those numbers should be close to each other. So in my head, I feel like I can get rid of 1 and 2. And I think my answer is 3 just by using logic. But let's check it out and let's do the math and let's see what makes sense. So when I see these cofunctions, I want us to think cofunctions equals complementary. I ran out of space. ARY. Well, what it means to be complementary means that those angle measurements add up to be 90 degrees. So what that means is if I take 4x and I add it to 3x plus 13, that should equal to 90 degrees. Well, 4x plus 3x is 7x plus 13 should be 90 degrees. If I subtract 13 on both sides, 7x is equal to 77. And then therefore x is equal to 11. And of course they gave us 11 because they're trying to throw us off. But it's asking us for the smaller angle. So I need to check and see which angle is smaller. So I'm going to check 4x. And I'm going to substitute 11 for x. And I get that angle is 44. And then I'm going to check 3 times 11 plus 13, which would be 33 plus 13, which would be 46. So between 44 and 46, 44 is my smallest angle. And I indeed was correct with my theory that those two angles should be close to each other in angle measurement. And this just justifies that algebraically. Capiche? So we could have gotten away with doing this without doing any work, just using logic. And I'm telling you, this is where we're going to eat up all of our points because a lot of these multiple choice questions, if you really think about it, there's only one answer that makes sense, or maybe two. but there's usually two ridiculous answers. And we want to be able to eliminate that so that we can maximize our time, so that we can spend more time in our part 2, part 3, part 4, where the stakes are higher. Moving on to question number 5. You know, I'm going to throw some circles in here because we didn't do very well on circles. So we need the practice. So a machine part consists of a circular wheel with an inscribed triangular plate as shown in the diagram. If SE is congruent to EA, so I'm just going to mark that on my diagram. So if these two segments are congruent and they tell me that SE is 10, so I know that SE is 10, and arc SE is 140. Arc SE is this arc right here. So that's going to be 140. Find the length of SA to the nearest tenth. Well, I know that SE is 10, so that must mean that EA is 10. And I notice if I have two congruent sides, my base angle theorem says that the angles opposite them are also congruent. So this is an isosceles triangle of some sort. Now, I don't know what the angles are at this point, but I know that they're congruent. And what I'm looking for is this side here, and I'm going to call it X. Now, this is not a right triangle. I'm looking for a side. I don't really know any angles right now, but I do know an arc length, and I'm going to notice that this angle SAE is an inscribed angle, and I know that my inscribed angle is half of my arc. So if my arc is 140, that means my angle is 70. Let me do a different color. 70. So that means that this is 70. So if those two are 70, that's 140. That means that angle E is 40. And ultimately, I'm looking for X, and I need to recall that if I don't have a right triangle, but I want to find a side in a triangle, I can use the law of sines, which says A over sine of A is equal to B over sine of B, and that's also equal to C over sine of C. So what I need is a angle and the side opposite it, and I can set that equal to another angle in that triangle and the side opposite that. So in this triangle, I'm looking for X, and the angle opposite X is 40. So I can say X over the sine of 40 is equal to, well, I need another set, and I have two. I can just choose any one that I want. So let's choose 10 over here over the sine of 70. Well, this is basic math. I can just go ahead and cross multiply. So X sine of 70 is equal to 10 sine of 40. When I divide by sine of 70 on both sides, I get that X is equal to, I don't know, I'm just going to use my calculator. So I'm going to go to my calculator. And I don't know if I mentioned before, you make sure that your mode is in degree mode. So I'm going to go into my calculator, and I'm going to type alpha, y equals, enter. And then I'm going to type in 10 sine of 40. And I'm going to divide that by the sine of 70. And I'm going to press enter. And they asked us to find the length to the nearest tenth. So that length is going to be 6.8. And that kind of makes sense. My two legs are 10, and that SA is 6.8. That kind of makes sense, so I'm just going to go ahead with it. Now, if I got a number like 140, I know that that's a ridiculous answer, and I have to go back and check my work. But 6.8 looks like a answer that I can deal with, so I feel confident on that. I think this was like a 4-point question. So you do what you can. Label your diagram, do what you can, and see what you can come up with. Now, maybe you forgot about law of sines, but you were able to find the inscribed angle. You could probably get a point for that. You were able to find all the angles in your triangle. Mark up your diagrams and provide something relevant. Something relevant will give you that 1 point that you want. We're not walking away with 0 points. It's not an option. Okay, so let's move on to number 6. Actually, before we move on, this is what I'm going to do. It's the end of the semester. Everybody wants extra credit. What I'm going to do right now is, if you have made it this far and you are listening and paying attention, what I want you to do is go to Google Classroom. Let me see if I can pull it up. Go to Google Classroom and go down to a post that I made on, let's do this post, where I got an A on my thesis paper because I am brilliant. No, just kidding. Okay, so go to this post on May 15th and let me know what you had for breakfast. So it's 1:44 a.m. right now. So I didn't eat breakfast yet, but I plan to have a bacon, egg, and how do I do and I feel so old, man. I can't find the and symbol. Oh, shift. Okay, here we go. Bacon, egg, and cheese. Whoops. So if you are paying attention, pause the video. Well, I'll give you a pause right now. And go to the post on May 15th and let me know what you had or plan to have for breakfast. All right, so we're back and we're on number 6. And Barry wants to find the height of a tree that is modeled in the diagram below, where angle C is a right angle. The height of elevation from point A to the ground to the top of the tree, H, is 40. And the distance of elevation from point B on the ground to the top of the tree is 80. And then the distance from A and B is 85 feet. So this is a lot of hoopla. However, they gave us a nice little diagram, and it helps because we can see what we're talking about. So we have a tree, we have some distance, and Barry claims that triangle ABH is isosceles. So let's locate triangle ABH. So this is triangle ABH. And in order for ABH to be an isosceles triangle, it needs to either have two congruent sides or two congruent angles. So he claims that it's isosceles, and it's our job to explain why he's correct. So we don't need to guess that he's correct or not. It is an isosceles triangle. We need to figure out why. So we need to get to finding some sides or finding some angles. So I'm looking at this triangle and it looks like this side, BH, is 85, but I kind of need to verify that. And I don't have any information right here to tell me that it's 85. So let's start working on some angles. So I see that angle A is 40 and I don't know anything else. However, I do see that we have this angle that is being shared, right? So we know that when we have a linear pairs are supplementary. So if angle HBC is 80 degrees, that means that angle ABH has to be 100 degrees. So if I know 2 out of my 3 angles, I'm good to go. I can say that angle A is 40, angle ABH is 100, so that means that this angle has to be 40 as well, because the sum of my angles have to sum up to 180 degrees. Well, I'm going to notice that these two angles are congruent, and the converse of my base angle theorem says that sides that are opposite congruent angles are congruent. So that must mean that this side right here is 85 degrees. So Barry claims that ABH is isosceles. Well, I think Barry is correct. And what we want to see here is a valid explanation. And you want to be very clear about how you came to find that he's correct. So I'm going to first say that angle ABH and angle CBH are supplementary, making angle ABH 100 degrees. Since angle A is 40 degrees, angle ABH is 100 degrees. Angle AHB must be 40 degrees because the sum of angles in a triangle is equal to 180. And then since angle A is congruent to angle AHB, line segment AB must be congruent to line segment BH because sides, opposite, congruent angles are congruent. And since triangle ABH has two congruent sides and two congruent angles, it is isosceles. Now, do you have to be this specific? Maybe, maybe not. It depends on who's grading your exam. But why leave things out when you have 3 hours to show what you know? You want to go ahead and show everything that you know so that they have no reason to deduct any points. So this is a lot, and it's winded and whatever. Yeah, it's a lot. Just do it. Just explain exactly how you were able to come to that triangle being isosceles so that you can make sure that you secure the maximum amount of points. So we're not done yet because it says determine and state to the nearest foot the height of the tree. So the height of the tree would be this right here. Whoops. HC. So if we knew what BC was, we can just use Pythagorean theorem. But of course we don't know what BC was because they want us to use trig, obviously. So I am looking at this triangle here, my green triangle. And what I know is that angle HBC, which is this angle right here, is 80 degrees. And segment HB, which is this segment right here, is 85 degrees. And this happens to be my hypotenuse because it's opposite my right angle. So if I'm going to go ahead and label my diagram, this is where I'm standing. I'm looking for my x, which is opposite of my angle. And I know that I have my hypotenuse. So if I'm using SOHCAHTOA, and I want to use which function uses opposite and hypotenuse, that's going to be sine. So sine of what? Sine of 80 is equal to opposite, which is x, over hypotenuse, which is 85. So x is equal to 85 sine of 80. And in my calculator, because I'm not doing that in my head, I'm going to put what was it again? 85 sine of 80. And when I press enter, I'm going to see that it asks us to the nearest foot. So that's going to be 84 feet. Whoops. That's going to be 84 feet. And that kind of makes sense. Because if I look at my triangle, it is less than my hypotenuse, but it's not far from my hypotenuse. And it makes sense because it doesn't look that much different from my hypotenuse. So now if I got a ridiculous answer like 12, I would have to go back to the drawing board because, it doesn't look 12. It looks kind of close to my hypotenuse. So I feel confident in this 84 feet. All right, moving on. As shown in the diagram below, a symmetrical roof frame rises 4 feet above a house and has a width of 24 feet. Well, here's the key word, symmetrical. So that means that we have some kind of line of symmetry. So that means that perhaps I can draw a line here and that's going to cut my shape in half. But let's see. Determine and state to the nearest degree the angle of elevation of the roof frame. So I'm looking for the angle of elevation that's from the ground up. And it's a great thing that I drew this line here because this could be at my altitude, which is perpendicular. So because it's symmetrical, I know that this side is 12 and this side is 12. And I know the length of this altitude because I know that it rises 4 feet above the house. So this length is going to be 4. Well, if I'm looking for my angle of elevation, that's going to be where I'm standing. And I'm just going to label my diagram. So what's across from my angle is opposite. And then this will be adjacent. So if I'm looking for that angle, I need to figure out which function I'm going to use. And what function uses opposite and adjacent? Well, that's going to be my tangent. So the tangent of theta is equal to opposite, which is 4 over 12. And if I'm looking for an angle measurement, I know that I have to use inverse function. So in my calculator, I'm going to type in second tan 4 over 12. And it's asking us to the nearest degree. So I'm just going to go to my calculator and second tan, and I'm going to click on alpha, y equals, enter, and 4 over 12. And to the nearest degree, that looks like 18 degrees. Whoops. Whoops. Whoopsie. Nah, it's 1:56. I got to speed this up. All right, let's move on to number 8. As modeled in the diagram below, a building has a height of 50 meters. They were really nice enough to give us the diagram. This is great. Sorry. The angle of depression from the top of the building to the top of the tree is 13 degrees. So what does that mean? From the top of the building, which is here, to the top of the tree, which is down here, the angle is 13.3. And I hope that we all see that. And the angle of depression from the top of the building to the top of the bottom of the tree is 22.5. 22.2. Sorry. I'm tripping, y'all. I'm tripping. I'm falling. I can't get up. Do we all see that? This angle here is 22.2. Now, we need to determine and state the height of the tree. So I need to figure out how tall this tree is. Now, we're definitely using trig, and we've seen questions like this before, and we know that when we see this kind of overlap, I somehow need to find out one and then find out the other, and then subtract it. So what I want you to look and notice, I want you to notice, since this building is 50 meters, I know that this length over here, the whole length over here is 50 meters as well. And if I'm looking for x, perhaps if I can find what this is, this segment here, let's call this y. Perhaps if I can find y, I can take y and subtract y from 50 to find what x is. But let's take a look to see how we can find y. Y is a part of this triangle here. And then X is a part of both. So I'm thinking, I don't know how far the tree is away from the building. So I kind of need to know that before I can find y. So I know that this side length is 50 degrees. So let's go ahead and see if we can find the distance. So let's call that z. Let's go ahead and take a look at this big triangle here that I'm highlighting in pink. And let's find z, because I know that side length is 50. So if I'm standing here at 22 degrees, what's opposite me is 50. And what's next to me is z. So if I'm using SOHCAHTOA, I can say I'm going to go ahead and use tangent, because tangent uses opposite and adjacent. And perhaps the tangent of 22.2 is equal to 50 over z. So if I can find z, then I can use z to find y, and then I can subtract y from 50 to find x. This is loaded. Whew, sheesh. Okay, let's do it. So we're going to cross multiply, and we're going to get z tan of 22.2 is equal to 50. And then we're going to divide by tan of 22.2. Ooh, do you hear my stomach? I'm starving. So z is equal to, I don't know, 50 divided by 22.2. Let's see. Alpha, y equals, enter. 50 divided by the tangent of 22.2 is 122.5213. So we always want to give ourselves some wiggle room. You don't necessarily have to, because it's asking you to the nearest meter, but I am just a force of habit. I don't like to cut myself short. So I'm going to give myself some wiggle room until the very end. So I'm not sure if cutting it off at 123 would hurt you or throw your numbers off, but I'm just not doing it. I'm going to give myself wiggle room, and at the very end, that's when I'm going to round. Now, I know that z now is 122.5. Let's get rid of this. 5213. And now I'm looking at my orange triangle, and I'm going to say that I'm standing here at 13.3. And now y is opposite, and my 122 is my adjacent. I'm still going to use tangent, but the tangent now of 13.3 is equal to y over 122.5213. And I'm going to go ahead and say that y is equal to 122.5213 tangent of 13.3. And obviously I'm putting that in my calculator, because I can't do that in my head. Alpha y equals, enter.
Find last minute Father's Day gifts he'll love every day at Kohl's.
Is this an ad? Are they serious? And I'm not paying for this, so yeah, I'll watch the ad. Okay, so what were we doing just now? Oh yeah, 122. Hold on, what am I doing right now? Oh yeah, I'm looking for y. So 122. 0.5213 tan of 13.3 is equal to, that's approximately 28.9628. So y is 28.9628, I believe. And now that I know y, I'm going to subtract that from 50, and then I'm going to round. So 50 minus 28.9628 is equal to, I don't know, 50 minus 28.9628. That's approximately 21. And I'm going to go out on a limb and say that the tree is approximately 21 meters. And that looks about right. This looks about 28. This looks about 21, especially since this angle is 13 degrees and this angle is 22 degrees. So if I take if I take 22.2 and I subtract 13.3, I get 8.9. So this angle right here is 8.9. So that's a little bit less than 13.3. So it looks like the tree length compared to my Y that I labeled, it's a little bit less than what I had up there. So this looks like an answer that I can feel confident in. So this is great for number 8. Okay, so we're going to pause here. And it is now 2:04. I am very tired. But after I do this, I'm going to grade your Regents review number 1 through 6. So what I'm going to do is I'm going to open all of them. So they're closed now. And I'm going to open all of them and I'm going to allow you to revise your answers. So I would hope that you looked at the videos and you now know what to do for those questions because you looked at the feedback. So you're going to go through and you're going to revise your answers and resubmit and submit your corrections so that I can change your grade. This is going to be great for those of you who didn't do it and got a 9 or whatever number I gave you. But now is your time to go back and revise your answers so that we can improve your grade. I just want to remind you that this is part of your summative category. So if you choose to increase your score, make sure that that is done before 4 p.m. So I am opening it now, literally as we speak, and you can do it and revise your work by 4 p.m. today on Friday, June 9th, and I will change your score, change your grade. All right, so we got 3 more left, 9, 10, and 11. I think we can do this. Let's try to get this done before 2:20 because I'm trying to go to bed, you know? I'm young. I need my rest. A rock climbing wall at a local park has a right triangular section that slants towards the climber. So we have a nice little picture here. The height of the wall is 5 meters, and the slanted section begins 1.2 meters up the wall. So here's my height. And here's my slanted section that's 1.2 meters high. So determine and state to the nearest hundredth the number of meters in length of this section of the wall that is slanted. So I'm looking for the hypotenuse. So I'm looking for this segment right here. And we notice that we have a triangle. So I'm looking for this segment here. Let's call this X. And I don't know anything about up here, but I do see that my whole segment is 5 meters. And my little section at the bottom is 1.2. So perhaps if I take 5 meters and I subtract 1.2, I should get this section right here. So I think that's about 3.8. I hope so because I'm not doing a calculator. So this is 3.8. And I know that the degree measurement is 14 degrees. So I'm going to label. This is going to be my hypotenuse because it's opposite my right angle. Opposite would be this, but I don't care about that because there's nothing there. So this is going to be my adjacent. So if I'm looking for X, let's go ahead and write out SOHCAHTOA. And in SOHCAHTOA, we want to figure out which function uses adjacent and hypotenuse. That's going to be cosine. So cosine of what? Cosine of 14. is equal to adjacent, which is 3.8 over hypotenuse, which is what I'm looking for. So then x cosine of 14 when we cross multiply is equal to 3.8. If I divide by cosine of 14 on both sides, we get that x is approximately, I don't know, let's go ahead and put this in our calculator. What was it? I think it was like 3.8 divided by, what was it, cosine of 14? I hope so. And that is approximately, to the nearest hundredth, 3.92. 3.92 what? Birds in the sky? 3.92 meters. Finish. Capiche? All right, two more. Two more, and then I'm literally going to bed. B-E-D. Oh, excuse me. As modeled below, a projector mounted on a ceiling is 3.7 meters from the wall, where a whiteboard is displayed. I think we did this in class once. The vertical distance from the ceiling to the top of the whiteboard is 0.41 meters, and the height of the whiteboard is 1.17 meters. Determine and state the projection angle, theta, to the nearest tenth of the degree. So I'm looking for theta, and I noticed that theta is not a part of a right triangle, because this is not a right triangle, right? I know I'm using trig because they're talking about theta. I see these overlapping triangles. I'm looking for an angle. I already know we're using trig. And I need to figure out this angle, and I can't because I don't have a right triangle. So perhaps if I take a look at this triangle that I am highlighting in green, if I take a look at this triangle and I'm able to figure out theta from that triangle, let's call theta there x. If I'm able to find out theta, which is x, and then I take a look at this triangle that I'm highlighting in orange. I can't believe I'm not using pink today. And I'm able to find this angle, let's call it y. What I can do is angle x minus angle y would be the theta that I actually care about. So let's start with our green and then work with our orange. So our green, which is this angle right here, if I use this angle, what's opposite it is this whole section right here. So one part is 0.41, the other part is 1.17, and when I add those two bad boys together, I get 1.58 meters. Well, that's going to be opposite, and then this is going to be adjacent. We know nothing about hypotenuse, so if I use SOHCAHTOA, I know that I am using tangent. So tangent of what? Tangent of x, because that's what we're looking for. That angle is equal to opposite, which is 1.58, over adjacent, which is 3.74. And if I'm looking for an angle, I know that I'm using inverse functions. So tan inverse of that ratio is equal to what angle? Let's see in our calculator. So in order to get the tan inverse, I click on second tan, and then what was it again? I don't remember. Okay, alpha y equals enter. I just looked at it. 1.58. Whoopsie. I'm delirious, guys. 1.58 divided by 3.74, and that's approximately 22.9021. So that angle x, is approximately 22.9021. Now, I need to subtract y from x, so let's figure out what y is. Well, if I'm standing here at y, What's opposite it is this 0.41. My adjacent is still my adjacent. So tangent of y is equal to 0.41 over 3.74. So tan inverse of that ratio is approximately, let's see, second tan. I think it was, I always put a fraction because honestly, I just don't have time to make mistakes with the parentheses. So I'm just always putting a fraction. But that angle measurement is 6.2561. So I know that y is approximately 6.2561. I hope that's what it was. And I know if I'm looking for theta, I'm going to take angle x and subtract it from angle y. Take angle y and subtract it from angle x. Y'all, it's 214. It's 214 and I'm tired. I'm really not that tired because honestly, I'm about to finish this and like watch something on Netflix because like I'm crazy. And you know, I'm gonna be up early in the morning. So if you guys need me, you can reach me. Call me, beat me if you want to reach me. Where's that from? Kim Possible? Okay, so the angle is about 16.6. So theta is 16.6 degrees. Finished. Whew. 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 One more. Okay, so number 11. David has just finished building his treehouse and still needs to buy a ladder to be attached to the ledge of the treehouse and anchored at a point on the ground. So this is nice because they gave us a picture, but then they enlarged it so we don't have to break our eyes. Okay, anyway. David is standing 1.3 meters from the stilt supporting the treehouse. This is the point on the ground where he has decided to anchor the ladder. So that's the point. This point right here is where he wants his ladder to be. The angle of elevation from his eye level. So his eye is up here. This is where his eye is. To the bottom of the treehouse is 56 degrees. So this angle here is 56 degrees. And David's eye is 1.5 meters above the ground. So from the ground to David's eye, which is right here, is 1.5 meters. And determine and state the minimum length of a ladder to the nearest tenth of a meter that David would need to buy for this treehouse. So what we're looking for is the length of this ladder. And had we known the length of the tree, this piece right here, we can just use Pythagorean theorem to figure it out. But we don't really know that. But what we do know is from the ground to his eye level is 1.5. So this little piece down here is 1.5. And what I kind of just want to know, what is this piece up here? Because if I know that piece up here, I can just use Pythagorean theorem, and that's my good old faithful. I can figure out what the length of the ladder should be. So I'm looking for x, and x is a part of this triangle that I'm highlighting in green. This is not really a nice color. I'm highlighting in, let's do pink. Pink? Can't really see either. All right, but you see the ladder, the triangle that I'm trying to talk about. I'm sorry, guys. All right, so I'm looking for x, and what I know is the angle is 56. I don't know the hypotenuse. However, I'm going to notice that down here from the bottom of the tree to his foot is 1.3, so it has to be 1.3 over here too. So if I'm labeling appropriately, this is where my angle is. So this is opposite and this is adjacent. So again, with SOHCAHTOA, I'm going to use tangent. So tangent of what? Tangent of 56 is equal to x over 1.3. So x tan of 56 is equal to, no, sorry guys, I'm delirious. I'm delirious. I'm delirious. X is equal to 1.3 tan of 56. And I'm going to put this in my calculator because I don't know what this is. Oh my God, I can't breathe. It's the smoke. 1.3 tan of 56. And that's going to be 1.9273. And remember, I'm somebody that gives myself wiggle room. So I'm not rounding until the very end. So x is equal to 1.9273. So that means that this little piece here plus that 115 will give me the side that I want. So if I add 1.9273 to 1.5, was it 1.5? Yeah. I get 3.4273. So this length here, let me erase everything. No, let me not erase it. I'm going to put it over here. This length here is 3.4, what was it? 273. 3.4273. And again, I'm looking for the length of the ladder. So that's going to be my x. And because this is a right triangle, because I know that David is creating this ladder that is perpendicular to the ground, he's not creating the Leaning Tower of Pisa, I can go ahead and use Pythagorean theorem to say that 1.3 squared plus 3.4273 squared is equal to c squared. And I don't know what this is, and I don't really care, so I'm going to put it in my calculator. And I'm just going to use my parentheses because it's going to make it nice for me. So 1.3 squared plus 3.4273 squared is equal to 13 point blah, 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 blah. So I'm going to put that here. C squared is equal to 13.4364. And what I'm going to do is I'm going to take the square root on both sides. So that C, which is my ladder, is equal to, I don't know. I'm going to figure it out though. Second x squared. And I'm going to put that in under my radical. 4364. I'm so exhausted, man. So I know that my ladder to the nearest, what was it? I think it was like 1/10 of a meter is 3.7. So 3 is 3.7 meters. And I have to think to myself, does that make sense? Can this be 3.7? And I'm going to go ahead and say, yeah, it looks right. It's the longest side and it's comparable. It looks close to what everything else is going on. So I'm just going to go ahead and say that this looks good to me and I'm finished. I'm done. I hope this video wasn't long. So 3 things. Number 1, tell me what you had for breakfast. I asked you to do that maybe 30 minutes ago. And I asked you to do that on the post where I told you guys that I got an A on my thesis. So tell me what you have for breakfast or what you plan on having for breakfast. And if you do that successfully by 4 p.m., I will give you 5 points on your lowest exam. That's number 1. Number 2 is go ahead and redo or revise or complete, for those of you who played yourself, any of the Regents practice Google Forms. So that's, we had 1 through 6. I have opened them up. Go ahead and revise it. Make sure to submit your work because without work, I will not take it. You do that, I change your grade. And is that all? If I said something else in the video, just do it and then I will honor it. But I hope you have an amazing weekend. I miss you guys so much. And I can't wait to see you on Monday. And I hope that everyone stays safe and stay indoors and wear your mask. Bye, bestie.